Hello everyone, my name is Bino, and in this video we'll integrate the following integrands using the U substitution method. We use the U sub method when we have the integral of a function which we call f of x and its derivative, the f prime of x dx, or when we have the integral of g of f of x multiplied by the derivative of the f of x dx. In our case, this square root will be the g, and the sin x will be the f of x, and the cos of x will be equal to the f prime of x. So the derivative of this sin x is equal to that cos x. So in these instances, we can use the U sub method. For our first question, we have to integrate 2x multiplied by the square root of 1 plus x squared dx. The derivative of the function which is inside the square root is equal to the 2x, so the derivative of this one is equal to 0, and the derivative of this x squared is equal to the 2x. So that's why we have to use the U substitution method, where we let the u to be equal to 1 plus x squared. We differentiate the u with respect to x. The derivative of the 1 is equal to 0, and the derivative of the x squared is equal to 2x. We multiply both sides of the equation by the dx, and that dx will cancel out, and the du will be equal to 2x multiplied by dx. We rearrange this integral, so we have the integral of the square root of 1 plus x squared, and we multiply this by that 2x and the dx. In the place of this 2x dx, we are going to substitute the du, because the du is equal to the 2x dx. So our integral in the form of u will be equal to the integral of the square root of, in the place of the 1 plus x squared, we substitute the u, and in the place of that 2x dx, we substitute that du. We express the square root of u as u raised to the power half multiplied by the du, and the integral of u raised to the power half will be equal to u to the power half plus 1 divided by half plus 1 plus our constant c, and this will be equal to u raised to the power half plus 1 will be equal to u to the power 3 over 2 divided by half plus 1, which is equal to 3 divided by 2 plus our constant c. We substitute back the 1 plus x squared in the place of the u, and the u is raised to the power 3 over 2, so even the 1 plus x squared will be raised to the power 3 over 2, and this is divided by the 3 divided by 2 plus the constant c. If we wish to simplify, this will be equal to the square root of 1 plus x squared, and this 1 plus x squared will be raised to the power 3, and 1 divided by 3 over 2 will be equal to 2 divided by 3 plus the constant c, and this will be our answer for our first question. For our second question, We have to evaluate the integral of ln x raised to the power 3 divided by x dx. We can rearrange our integral as the integral of the ln of x raised to the power 3 multiplied by 1 over x dx. The derivative of this ln x is equal to 1 divided by x, so we have to use the U sub method. We are going to let the u to be equal to the ln x, and the derivative of the u with respect to x will be equal to the derivative of the ln x, which is equal to 1 over x. We multiply both sides of the equation by the dx, and that dx will cancel out, and the du will be equal to 1 over x multiplied by the dx. So in the place of 1 over x multiplied by the dx, we will substitute the du, because this du is equal to 1 over x multiplied by the dx. We rewrite our integral in the form of u. So we have the integral of, in the place of the ln x, we are going to substitute the u, because we said that it's equal to the ln x. And since the ln x is raised to the power 3, even the u will be raised to the power 3. And in the place of 1 over x multiplied by the dx, we substitute the du. And this will be equal to the integral of u to the power 3 du, and the integral of u to the power 3 with respect to u will be equal to u to the power 3 plus 1 divided by the 3 plus 1 plus our constant c, and this will be equal to u to the power 3 plus 1 is equal to 4 divided by the 3 plus 1, which is equal to 4, plus the constant c. So in the place of the u, we bring back the ln x. So we substitute the ln x in the place of the u, and since the u is raised to the power 4, even the ln x will be raised to the power 4 divided by 4 plus our constant c, and this will be our answer for our second question. For our third question, we have to integrate the arctan of x raised to the power 8 divided by 1 plus x squared. The reason why we are going to use the U sub method is because the derivative of the arctan of x is equal to 1 divided by 1 plus x squared. We can choose to rewrite our integral as the integral of the arctan of x raised to the power 8 multiplied by 1 divided by 1 plus x squared dx. We let the u to be equal to the arctan of x, and we differentiate the u with respect to x, and the derivative of the arctan of x is equal to 1 divided by 1 plus x squared. We multiply both sides of the equation by the dx, and the du will be equal to 1 divided by 1 plus x squared dx, and our integral in the form of u will be equal to the integral of, in the place of the arctan of x, we substitute the u, and the arctan of x is raised to the power 8, so even the u will be raised to the power 8. And in the place of 1 divided by 1 plus x squared dx, we will substitute the du, because the du is equal to 1 divided by 1 plus x squared multiplied by the dx. So we'll substitute the du, and this will be equal to the integral of u to the power 8 multiplied by the du, and the integral of u to the power 8 with respect to u will be equal to u to the power 8 plus 1 divided by the 8 plus 1 plus the constant c, and this will be equal to u to the power 8 plus 1 is equal to 9 divided by 8 plus 1, which is 9, plus the constant c. We substitute back the arctan of x in the place of the u. So where there is u, we substitute back the arctan of x. And since the u is raised to the power 9, so even the arctan of x will be raised to the power 9. And we divide this whole thing by the 9 plus our constant c. And this will be our answer for the third question. For our final question, we have to integrate the square root of sine x multiplied by cos x dx. The derivative of this sine x is equal to cos x, so it will be much easier for us to let u to be equal to the sine x, since it's already inside the square root, and the derivative of the u with respect to x will be equal to the derivative of the sine x, which is equal to cos x. We multiply both sides of this equation by the dx, and the du will be equal to cos x multiplied by the dx. Our integral in the form of u will be equal to the integral of the square root of u in the place of the sine x, and in the place of the cos x dx, we are going to substitute the du because it's equal to the cos x dx. We express the square root of u as u to the power half multiplied by the du, and from here the integral of u to the power half with respect to u will be equal to u to the power 1 over 2 plus 1, and this will be divided by the 1 over 2 plus 1 plus our constant c. From here we simplify, so u to the power half plus 1 will be equal to 3 divided by 2 divided by half plus 1, which is equal to 3 divided by 2 plus our constant c. We substitute back the sine x in the place of the u. So where there is u, we substitute the sine x. And since the u is raised to the power 3 over 2, even the sine x will be raised to the power 3 over 2 divided by the 3 over 2 plus our constant c. We can leave our answer here, or we can further simplify, and this will be equal to the square root of sine x raised to the power 3. The 1 divided by 3 over 2 will be equal to 2 divided by 3 plus the constant c, and this will be our answer for this final question. So if you have any questions, you can leave them in the comment section below. Remember to subscribe, like and share this YouTube channel with your fellow mates.